Integrated rate equation is an equation that relates the concentration of reactant and the time elapsed. Take note, there are different mathematical forms in different orders of reaction. Initial concentration is denoted as A0, while remaining concentration is denoted as A. Time elapsed is symbolized as T and coefficient is symbolized by A, whereas K is the rate constant. There are three orders of reaction: zero order, first order, and second order. In zero order, the difference between the initial concentration and the remaining concentration is equal to the product of rate constant, coefficient, and time elapsed. In first order, the ln of the quotient of initial concentration and remaining concentration is equal to the product of rate constant, time elapsed, and the coefficient. In second order, the difference between the reciprocal of remaining concentration and the reciprocal of the initial concentration is equal to the product of rate constant, time elapsed, and the coefficient. Half-life is the time required for half of the reactant to be converted into product or products. It is denoted as T with a subscript of 1/2. Half-life also has three orders: zero order, first order, and second order. To devise the equation of the half-life in zero order, we can use the zero order formula that was previously discussed. In half-life, the remaining concentration is equal to the initial concentration divided by 2. We're going to substitute this to the equation. Since we are looking for the half-life, we want to know the time when the initial concentration is halved. So we're going to isolate T. Simplifying, we'll get the equation of the half-life in zero order, which is initial concentration over twice the product of rate constant and coefficient is equals to half-life. We'll use the same derivation method for the half-life of first and second order. And we will arrive at the equation half-life is equal to ln2 over the product of rate constant and coefficient for first order. And half-life is equal to the reciprocal of the product of initial concentration, rate constant, and coefficient for the second order.